Well, I'm here at the Smart E Europe with Claudio Godinho, EU Service Director for Aiko Solar. And at the show this year, Aiko is doing some live testing of cells and modules right on its booth. And Claudio is going to show us, treat us to a demonstration of some of those tests. Claudio, could you first tell us a bit about what you're testing, what you're looking for with this demonstration?
And here we are showing our Aiko ABC models that are our back contact technology that we have in our all models. In this moment we are promoting our second and third generation of models. And we have a set of tests to show the difference on the performance of our models, on the shading optimization, on the hotspot temperature that's much lower than the regular models that are on the market, on the mechanical resistance that our models much more mechanical resistance to microcracks, and we can show these features with special tests that we can see on site here.
Okay, well, let's go and have a look at the tests then. And well, here we have the partial shading optimization test. Claudio, could you tell us a bit about this test and what you're looking for?
Here we are doing a simulation of the shading optimization that can happen on our models. Here we have two lights for two different models. The lights are simulating the sun, and here we have the Aiko ABC model, and on the side we have a TopCon model. On this moment, there are no shadows on the model, and we can see the performance of the models on these light stripes or on the movement of the cars. Okay. Now I'm going to ask the help of my colleague, and I'll start to make some shadows, and you can see how the movement of the cars will change and how the LED is changing the performance. Okay.
Okay, let's have a look.
Starting here, we start to put this leaf. Imagine that the leaf will fall down on the model. My colleague will repeat the same on the TopCon model, putting on the side. And you can see how these performances are changing on the movements of the car, on the LED stripes, how it's changing. We can increase even for a bigger shadow, for example. And you can see the same, the car is stopping. With the Aiko model, of course, we are affected the shaded area, but the power can still go out from the model and changing the movement.
Okay, and we see on the other side here, this is a TopCon module, is that right? And the car just stops as soon as you
remove the shadows and everything got to normal. We're going to do a different situation. We're going to change the light and just turn on the light in the middle. And now we have a situation that the shadow from the tree is affecting both models. And we can see the same on the LED stripe under the car. Okay? Real situation that can happen in many kinds of installations, okay, that affecting the performance. And our shading optimization is all bringing a huge performance on this part. Even in situations that you use a microinverter, many times if two diodes get activated on the TopCon model, the voltage of this model will be so low that will not activate the inverter, and the inverter still not work, even in these kind of situations.
And can you tell us a little bit about some of the innovations that go into Aiko's modules that make this possible?
Yes, this is related to a technology that we have on the back contact on our models. When the cell is shaded on a regular cell, the resistance of the cell will increase a lot. Okay? So this resistance will be so high, and on the TopCon cell, because we have positive on the top and negative on the back, the current will flow from top to down. Okay? So need to cross all the thickness of the cell. So the voltage drop, when the current flow is so big, that automatically will activate the bypass diode. Okay. In Aiko case, because we have the back contact with the positive and negative on the back, side by side, okay, when the cell is shaded, the resistance increase, but the current can flow from positive to negative with a minimal voltage drop. So the bypass diode will not get activated. The shaded area is affected, okay, but will not automatically activate the bypass diode, and we can still produce the energy in this part.
And we see today plenty of manufacturers kind of investigating back contact. Aiko kind of is well ahead of a lot of them on this technology. I think one thing that's held it back in the past is that it's a little bit more expensive to produce compared to some other cell technologies. What's the situation there currently?
What Aiko have done is on the moment that we decide to go on the technology, we decide to go all in. Okay, we have been, and we still are a cell manufacturer. We manufacture TopCon and the PERC cells before, and in some moment of the boom of the PV, we earn a lot of money and decide to bet all this money on this technology. Okay, and one thing that we have done is develop a way to manufacture this back contact technology with a really competitive costs. So now we are starting to be competitive, and we have such a huge growth that we are getting on the market on these days, because our price of our products, the benefits we bring, we start to be really competitive on this part.
And will back contact be your focus for the future, for the foreseeable few years?
We are all in back contact technology.
Okay, thank you very much. And well, let's have a look at the next test if we can. Okay, well, more live testing of Aiko's back contact modules are going on here at the Smarter E. Here we have the high temperature hotspot formation test. Claudio, can you tell us a bit about what we're looking at here?
Yeah, what we have here, we have the Aiko ABC model with ABC cells, our Aiko technology, and on the side we have a TopCon technology. Okay. On this moment we have this artificial light simulating the sun, and we have put this block making a shadow on the cell of the model. Okay. Now here we have this thermal camera that are measuring in real time the hotspot temperature of these models. Okay. So if we go better here to TV, you can do the reflection. What we see here is that on this moment, on the TopCon model, we have a hotspot temperature of around 164 degrees. Okay. If you look to the maximum temperature on the Aiko ABC model, we have 92 degrees. Okay. So we have a huge difference on the hotspot temperature. Okay. This is quite important because in many situations the roof have a shadow always on that spot. So the model we have always shaded during their lifetime. And if the encapsulation of the model is a polymer, so model every day is subject to this temperature of the hotspot, in the long term the encapsulation starts to be degraded faster and can affect the performance of the model. Because of Aiko ABC technology, our hotspot temperature is much lower. So this will help to have a better performance in the long term from the Aiko ABC model.
And what's really the risk here of a hotspot forming on a module? What can it do to the performance?
In the most extreme case, okay, this is affecting of course, the resistance is really high. We are dissipating a lot of energy there, so automatically bypass diode is activated for safety. Okay? Imagine that the bypass diode situations can fail. You can have the risk of a fire here, so even reduce the fire risk much lower on this case too.
Okay, so worst case scenario, you can have the whole thing catch fire basically. How common actually is that to happen?
Really rare cases. Okay, but anyway, we are promoting this part, so we are keeping this to increase the safety of the system in a global way.
Sure, and yeah, you see there a significantly lower temperature on the back contact module
for a full day, and you see this is the dynamic values that are changing, but the temperature keeps in a really good condition.
Okay, and again, could you tell us a little bit about what the innovation is that goes into keeping?
It's a similar innovation that promotes to our shading optimization. Because the same thing, when the cell is shaded, the resistance of the cell is really high, and the current want to flow through this cell. So it's dissipating a lot of energy there. Okay? In our case, because we have positive and negative on the back, the current can flow with a minimum voltage drop, less energy being dissipated. And we are seeing this here in lifetime. If you dissipate less energy, less heat, less hotspot temperature.
Okay, thank you very much, Claudio Godinho from Aiko. Well, we've had a look today at some of the performance testing that goes into these cells, and now we're going to talk a little bit about the finished product. Claudio, this is Aiko's latest module, I believe. What can you tell me?
Our Aiko ABC third generation model. We call it NeoStar 3P because this is the white pack sheet black frame dual glass model. Okay, and what the innovations we are bringing in our third generation? We are increasing the cell area on the model. With this we can have much higher efficiency and much higher power. And if you see under 2 square meters, you can reach more than 24.3% efficiency on this model. Okay? What we are doing here on innovation on our side, we are the bus bars that transmit the circuit, we are moving it to the back side of the model. If you look on the back of the model, you can see here that you move the bus bars to the back side, and on the top the same, so you can make the circuit with all these parts hidden on the back side of the model. So the front face can have more cells to produce more energy, so increase the power and the efficiency of the model.
Okay, but, I mean, a lot of manufacturing today is bifacial modules. What does this approach do to the kind of bifaciality?
This is a residential model that normally is coplanar on the roof. So, and on this part, because we have the back contact and move the bus bars, we are not so worried about the bifaciality rate, but still have a bifaciality rate around 30%.
Around 30% with this approach, okay.
For the bigger models, of course, the bifacial models, we are being more careful and we are increasing the bifaciality rate to 75%.
To 75%, okay. And what do you actually have to be careful with to achieve that 75%?
You can see here on the back of this, for example, bigger model that we have here, bifacial model. Okay. That a model with a 24 generation 2, 24.1% efficiency. And if you look on the back, sorry. You can look here on the back and you can see that we are being much more carefully on the moving of the bus bars, so we can optimize the bifaciality rate on this model. And on this model, yes, we can have a bifaciality rate around 75%.
And now we take a quick look at the what could be the future for Aiko Solar with a prototype of its intelligent navigator module. Claudio, what can you tell me about this?
Yes, here we have our navigator model that brings even innovation again that we are bringing more for everything we have been talking today. We bring another innovation that is the monitoring of the model. If you look here on the back of this model, you can see on the diode box it's a little bit bigger in one of the sides of the model, because integrating here on this diode box, we are integrating the monitoring of voltage, current and power of this model. Okay, so this can help really a lot, the monitoring for O&M performance of the model. Okay? We are integrating this communication with some brands of inverters, so automatically the inverter can receive these measurements from the model.
Okay, so it's similar to a microinverter approach, or?
I will not say that, because this is just measuring. So it's just monitoring, just measuring the voltage and the current and the power of the model. Okay, so it's being to provide extra benefit for the operation and maintenance. Imagine that you have a huge rooftop with many models, and if you can monitor a model by model, at least you will know where is the problem someday, or if you need to clean the models. So you can really optimize your operation and maintenance.
Okay, so it's about having that more granular data on your performance. Again, is there an impact on the cost with this approach?
With this approach that we are getting, the impact on the cost will be really small for the benefits that we will bring for the O&M. Okay, as you see, just a small increasement on the diode box, that we increase this electronics. They'll be self-power activated by the model, and they'll start to communicate with the inverters and sending this information.
Okay. And is this data logger, is this something that Aiko produces in-house or with a partner?
This is still in innovation. We are still developing this technology, and we start talking with the partners, especially the inverter manufacturers, that can receive this information and integrate in their monitoring platforms.